Hello everyone, on today's Mr. Wesley Explains, we're talking about non-Newtonian fluids. Now this lesson was inspired by Ms. Felter's reading of Dr. Seuss's Bartholomew and the Oobleck. So if you want the full effect, make sure to go listen to her story first and then come back and watch this video and we'll make some. Alright, for now, let's get started. Today's materials are 1 cup of water measured out, 1.5 cups of cornstarch. There's the measuring cups I use to do it, and a nice sized bowl to mix it all together in. Simple enough. Go grab those materials and let's get started. All right, we have our 1.5 cups of cornstarch measured out in the bowl. Now we're ready for our cup of water. Just dump it on in and get ready to get those hands dirty. Get to mixing. All right, we'll see you after I'm done mixing. All right, so we have our finished product here. Our oobleck is made. We actually had to alter our recipe and add another 1/2 cup of cornstarch to get it to act the way we wanted it to. But if you were doing this yourself for the first time, I would just reduce the water. Play with it until you get the recipe correct. So here's what's so cool about oobleck. It doesn't behave like liquids that you know. When you slap it, it doesn't even splash. But if you go to pour it, and do it slowly, it behaves just like a water would. It pours easily, it takes the shape of its container, but only when you do things slowly. If you do things too quickly and add stress to it, then it acts more like a solid. So let's talk about why these non-Newtonian fluids act the way they do. So why is oobleck so much fun to play with? Because it's a non-Newtonian liquid. Non-Newtonian liquids don't follow the law of viscosity that most liquids do. Water is a great example of a regular Newtonian liquid that follows the law of viscosity. The law of viscosity says that the liquid will continue to flow in its normal way, no matter what happens to it, unless you change the temperature. Now, if I make the water really, really cold, it'll freeze, or if I boil it, it'll turn to a gas, just like in our last video. But if you splash it, it'll act like a liquid, no matter what stress you put on it, unless you change the temperature. But non-Newtonian liquids don't follow those same rules. The oobleck is a great example of a non-Newtonian liquid. The particles in it, the cornstarch, is suspended in the water and not dissolved. So when you slap it, the big giant cornstarch particles don't have time to move out of the way of those smaller water particles. See, in the water, the particles are all the same size. So when you slap it, they're able to get out of each other's way. They flow normally. But not so with the non-Newtonian liquids. Another good example of a non-Newtonian liquid is like heavy cream. So when you shake heavy whipping cream in a container, it'll eventually turn into whipped cream. And if you keep shaking it, eventually it'll turn into butter. Now, not all non-Newtonian liquids behave the same. The cream and the oobleck, when we put it under stress like slapping or shaking, become more solid. Honey and ketchup are examples of non-Newtonian fluids, but they actually do the opposite. They become more liquidy or more viscous when you put them under stress. So if you take honey and you shook it for a very long time or stirred it for a very long time, it would almost turn into a liquid sort of similar to water. Ketchup would do the same thing. When your ketchup is half empty and you have it stuck at the top, what do? You give it a nice shake and it turns liquidy and comes down to the bottom. So those are examples of non-Newtonian liquids that actually do the opposite and become more liquidy under stress. One last final example of a non-Newtonian liquid is the earth that the houses were built on in Canterbury, New Zealand back in 2010. In 2010, an earthquake struck in Canterbury, New Zealand. It was on the South Island. And the clay and silt that the houses were built on were solid. However, when the earthquake shook and put stress onto the land under it, the land actually turned into a liquid and caused lots and lots of damage because the houses actually sank. It was a very unfortunate tragedy, but it was a real-life example of a non-Newtonian liquid. All right, I hope you've enjoyed learning about non-Newtonian liquids. As always, I will see you on the next video. And if you haven't watched Ms. Felter read the Dr. Seuss book about oobleck, do that now. All right, bye for now.